5x plus 2. Number 2, I think should be negative 45. Number 3 is really weird. I feel like, as I was going back over this, I feel like number 3 might almost have no solution. We can review that one a little bit if you want. And number 4, negative root 7 or negative 1 root 7. Yeah, so let's start at the top. Number 1. Any questions that I can handle for you there for number 1, the distributive property and adding like terms? Did any of you guys have 2 plus 5x instead of 5x plus 2? So you all realize that that is a valid, correct answer, right? 2 plus 5x, 5x plus 2. Well, what we started doing yesterday with polynomials, do you guys see how 5x plus 2 is written in descending order? So let me ask you a question. If number 1 is a polynomial, what special name would that polynomial get? Binomial, yes. What's the degree of that binomial? Degree 1. What's the lead coefficient?
2.
5. 5, yeah. Okay, we'll practice that some more today. Number 2, I got negative 45. Any questions on details there with number 2?
Could you redo number 2 for me?
Sure. Okay, so number 2, I think that it's best if we do the whole empty parentheses thing. So I'll start off with that. So I'll say g of negative 3 equals, and I'm just going to plug things in with empty parentheses. So be negative 3 squared minus 12 minus absolute value of 3 times negative 3 quantity squared plus negative 3 cubed. So I'm not using a whole lot of brain power there. I'm just basically wherever I see an x, I'm replacing it with negative 3. So I'm not trying to do any figuring or calculating or anything. I'm just going plug, 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 and then I'll start trying to do some thinking. That make sense? Okay. Order of operations says we need to do work inside parentheses first. And so I see a pretty decent amount of work to be done in parentheses. Not yet, but now let's think this over. I'll highlight it. What is 3 times negative 3?
9.
Negative 9.
But
then you absolute value it, and you get 9. So it'd be 12 minus 9 squared plus negative 3 cubed. There's still a little bit of work to be done in the parentheses there, so I'll do that here. I get negative of negative 3 squared minus, of course 12 minus 9 is 3. That's right. And I go there. Notice I'm not trying to do a whole lot of these steps in my head. I'm taking my time, but I think in the end, if you take your time, you might end up being a little bit faster because you're doing less of it in your head, and you'll hopefully be more accurate too, right? Okay, and then I've cleared all the parentheses, all the work to be done in the parentheses, but I have not done my exponents, and you can tell there's 3 of them, right? 3 exponents to be done. So the first one, this negative does not go anywhere. It's still there. What's negative 3 inside parentheses squared?
9.
It's 9, so it ends up being negative 9, right? So there's that. Minus, how about positive 3 in the parentheses squared?
9.
It's also 9. So negative 9 minus 9 plus, how about negative 3 in the parentheses cubed? That's your negative 27. So basically, when you look at the final step here with the addition, it's basically left 9, left 27. That makes sense on the number line? Left, left, left. So if I go left 9, left 27, that's where I come up with negative 45. So that was my thought process, right? I think it's important to try to communicate that. Any other follow-ups on number 2? So like I said, number 3, when I was doing it here a few minutes ago, struck me as kind of weird. So maybe it'd be a question better, maybe should be maybe edited or something. Do y'all see how my vertical line right there is that black dotted line? That's my first one. That's x's greater than 1. So what I did is I shaded to the right of the black line. So I shaded there. Then the blue line is the second line. Y is less than or equal to negative x means a slope of -1, plus 3 means y-intercept of 3, does it not? And I'm less than there, so the 0, 0 works. And so for the blue line, I'll shade this in blue. So do you all see how at this stage, it looks like maybe that lower right-hand corner is going to be part of our answer? And what was really strange is when I got the other one, the final line in slope-intercept form, I got, let's just make sure I did that part right. Yeah, I subtracted 5x. I divided by -2, and I got that green line, right? Y-intercept of 3, slope of 5/2. And so when I shade there, 0, 0 doesn't end up working. And so I end up shading up here where I'm putting these green marks. And do you see how at no point will all 3 shadings overlap? Do you see what I'm getting at? This is kind of weird. I would never probably do this to you on a quiz or a test because I'd try to make it work in a way that you're familiar with. So I'd say there's got to be some little typo in here beyond just the whole equals and less than thing. But this one, I think my final conclusion would just be there is no solution because the shadings never overlap. I don't think we could find any one point that works in all 3 of them. So who knew? That's the conclusion I would come up with. All right, and then finally, number 4, we had to do simplifying on the last 2. And so I had 1 of them. I added 4 of them, so I had 5 of them. Took away 6, so I got -1. That's where I got my -1√7. Sure. Okay, so when you first look at this, in order to add radicals, you need to have like radicals. So at first glance, when you look at it, you think to yourself, square root of 7, square root of 28, square root of 63, they're all different. So I'm done, I can't do this. And I could understand why maybe somebody would think that. However, you need to investigate a little bit further beyond just that and realize that while the 7 is prime, the 28 is not, the 63 is not prime. And so since the 28 and the 63 are not prime, they might simplify down to a simpler form. So what I would do is I would need to get my prime factors here. And this is what we were working on this morning. So it would be square root of 7, 2 times the square root. Now 28 is really 2 times 2 times 7. Minus 2, and 63 is really 3 times 3 times 7. So there's a pair of 2's in that one, and there's a pair of 3's in the other one. So remember, if you've got a pair of 2's inside the radical, it's the same as 1 2, a single 2, on the outside. So I could rewrite this as square root of 7. Oh, that's in a bad spot. I could rewrite this as the square root of 7 plus 2 times the square root of 7. And the pair of 3's would come out as a single 3, so it would be 2 times 3 times the square root of 7. And then, of course, 2 times 2 is 4, so you'd get square root of 7 plus 4 root 7. 2 times 3 is 6, so it would be minus 6 root 7. And then you just add your coefficients. Like I said, if you've got 1 root 7, and then you've got 4 more, how many do you have? 5 of them. 1 plus 4. I'll keep going here. Let's see, I'll come up here. So 1 root 7 plus 4 root 7 minus 6 root 7. If I add the first 2, I get 5 root 7. And then if I have 5 of them and I take away 6 of them, there's -1 of them. So -1 root 7. All right. Anybody else with a question? Okay, cool. So we're going to do a little more of a traditional class today. So if you all would, go ahead and push forward in your notes. Like I said, a little more traditional where it's going to be a little more directed by me. And I've got this set up. I've got I think I've got 3 sets. Yeah, I've got 3 sets. And really, honestly, we only have to do the first one. So I want to do the first one kind of with you, and maybe I'll have you guys try the second one on your own. And we can kind of use that as a little bit of an exit ticket. So if you would, let's review how you add like terms. So you're going to want to be focused. You're going to want to be plugged in to this. So take a look at the very first example there. It says review how to add like terms. What do you think 4x to the fourth plus 81x to the fourth would end up being?
85x to the 4.
So 85, heard a lot of 85s. 85x to the what? Fourth is correct. That's right. So when you add your like terms, the variable and the exponent, they stay the same. When you are adding like terms, adding, the variable and the exponent stay the same when you add the coefficients. How about number 2? Do you guys see any like terms there on number 2? How many like terms are there? There's 2 of them. So isn't the first one like the third one? Okay, so why is the middle term not like the first and the third? The y, that's right, it's y to the first instead of y squared. So if I tried to add the first and the third, what's my new coefficient for the first and the third combined? It's 11. Right, so it'd be 11x squared, y squared, and then you still have that plus 2x squared y. And that's as far as you can take that one, as far as you can go. Welcome. Okay, so that's how you add like terms. So what we're going to do here is we are going to add some polynomials together, and then we're going to subtract some polynomials and kind of see how it all goes. So you got to be focused. This is going to be a very quick shot. We're not going to spend a ton of time on this, so be ultra focused for a couple of minutes and you should be in good shape. So number 3. Number 3 says add. And I'm going to give you what I hope is a very clear procedure. When you are adding 2 polynomials, obviously there's parentheses around them. You can tell right here because of that symbol, we are adding them together. We're not subtracting them, we're not multiplying them, we are adding them. So here's what you do. When you're adding some polynomials together, you simply drop the parentheses and you add your like terms. So maybe my second step would look like this. 3c squared minus 2c minus 5 plus 4c squared minus 7c plus 3. It's going to drop the parentheses off altogether. And once I've dropped those parentheses off, I'm going to add my like terms. I'm just adding these together. This is one of the more straightforward processes. So I'll go backwards here just for fun. What term is like the 3? The 4c squared is not like the 3. Oh, you're not reading what I'm doing. Read my screen there. What's like the 3? I didn't say 3c squared. I said what's like the 3? The negative 5. That's right. So negative 5 plus 3 is? You said it. Yeah, negative 2. Okay. I'm just going to kind of mix these up. I do have a reason for it, so just stay patient. What is like the 3c squared?
The 4c squared.
The 4c squared is like it. When you add those up, what do you get?
7.
That's right. So plus 7c squared. And then those last 2 terms that are not marked, are those also like terms?
Yeah.
What do you get when you add those up? So it'd be minus 9c. Okay. So at this point, I've added my polynomials together, but I wanted to kind of bring yesterday into today. And the way with my current answer, the way it's written up there, is that in descending order? Can anybody put it into descending order? What do you think, Ellie?
It would be 7c squared minus 9c minus 3.
That is definitely in descending order. Well done. Notice how the exponents go 2, 1, and then there's no c. I also want to review this with you guys. This is a polynomial. It's got a special name. What's its special name? Why? 3 terms. It's a trinomial. There you go. Okay, so this is from yesterday. I just want to review this with you. What is the degree of my trinomial? 2. Aren't you just looking for the highest exponent there? So it's degree 2. And what is the lead coefficient?
7.
7 is the lead coefficient. So I'd want you to be able to identify those things. I want you to be able to put it in descending order. Yeah. Okay, how are we doing? Okay. Now the other one, can anybody tell me the difference between number 4 and number 3? Subtraction. Yes, we got to pay really close attention to the symbols and what they mean. Up here on our first effort, obviously it's addition. Down here, it's now subtraction. And you got to be honest, isn't subtraction a little bit different from addition? They are not the same. They're related, of course, but they are not the same. So I wanted to give you the process here. Here's how you subtract polynomials. On the first polynomial, you drop the parentheses. So it would just be 3y squared minus 4y minus 6. On the second polynomial, you have to distribute the minus sign before you drop the parentheses, right? You've got to distribute that minus sign because we're subtracting the whole thing. We're not just subtracting the first term, we're subtracting the whole polynomial. So it would be minus 2y squared plus y minus 9. As I distribute that negative across, I get that. So you drop the parentheses on the first, distribute the minus sign to the second. And once you get into this stage, we're just going to add our like terms. So what do you all think is like 3y squared? You got to be careful. Remember, the sign in front of the term belongs to the term. So it would be negative 2y squared. When I add those up, what do I get? Y squared. Good. Okay, so then what is like negative 4y? Okay, when I add up the negative 4y plus the y, what do I get? Yep, negative 3y. And those last two terms that are not marked, are those like? And what do you get? Negative 15. Good. Okay, what's the special name for this one? Trinomial is correct. Degree? It is also second degree. That's just a coincidence. They're not all second degree. We will look at a lot of second degree, though. What about the lead coefficient? 1, right? So if it's just y squared, there does not appear to be a coefficient. It's always understood to be 1y squared. Okay. How we doing? All right. So I would like for you guys, while I'm getting organized here, I would like for you guys to try one more. It's on the next page. I want you to pick this, or I'm going to pick this for you. I want you guys to try number 6. I think number 6 would be a really good one for you to do. I'll get myself organized here in just a minute and show you an answer. Of course you can. What are you trying to compare it to? It's got to have the same exponent. Yeah, not just the same variable only, but also the same exponent. Okay, so I'm going to go ahead and start showing you this. Maybe you've come to a good spot. If you're not there yet, keep working. But I'll show you what I've got up here. You're looking for a good first step. That one looks pretty good. Good. Okay, so I've got an answer up there. As far as the final subtraction, I got 2y cubed plus 9y squared minus 11y. As I'm peeking over shoulders, I'm seeing a lot of those. That's great, right? Let's review from yesterday. Special name for this one. Yeah, it's another trinomial. They've all been trinomials today. It won't always be that. What is the degree? This one is degree 3, right? The highest exponent on the terms is 3. Degree 3. How about the lead coefficient?
2.
Yeah, 2y cubed, right? So there you go. There you have. How we stand? Like, that's it, guys. If you can do those couple of examples, you're doing okay. You're going to want to practice a little bit, right? That's how it goes. All right, wonderful. So if you guys would put your notes away, grab some Fort making materials. We have our concept quiz 13 over square roots we're going to get ready for. Please get ready for that.
I actually get some more since I wasn't here yesterday.
No, we didn't do this yesterday at all. Like,
No.
yeah. Usually with our quizzes, there's like a couple days between the finishing of the concept and then the quiz itself. So whether you were here or not yesterday doesn't really make much difference.
Oh, when do we get the quizzes back?
I've got them. I'm going to hand them back to you here before we go. I'll probably do it while you're doing your
I
quiz.
just did 1, 2, 3, 4, 5, 6,